we're supposed to integrate this, this is the same as saying that d dx of x with the power x. Okay, note that if we have e raised to the power natural log of x is equals to x. Okay, so if that is the case, then we can say that d dx of that, okay, into bracket e raised to the power natural log of x into bracket all x out. This can be written here as d dx of e raised to the power x natural log of x. Okay, but e, the base is just a number. It's just a number. Okay, just a number. So if we look at this very carefully, okay, we see that this can be a product. So if when I bring e out, so e raise the power x natural log of x into bracket. You see, we have to apply product rule d dx of natural log of x plus natural log of x d dx of x. Okay, isn't that beautiful? Now, applying the product rule over here, this expansion will give us g x raised to the power natural log of x into bracket. When we differentiate this one, this is 1 over x times 1 plus this will be natural log of x. So a further expansion, okay, so this will be e raised to the power x natural log of x into bracket. This will be 1 plus natural log of x. This is our answer. But we can also tackle it from a different angle. How do you do that? Okay, different angle. Let y equals to x to the power x. So this is alternatively, okay, thus y equals to that. Let's take natural log to both sides. So this will be natural log of y is equals to natural log of into bracket x. Okay, this, when we work it out, this will be 1 over y. Okay, 1 over y. Okay, dx. Okay, the y-dx is equals to product. So this Okay, this one can also be written as x natural log of x. So this, we can use product rule to break it down. So this will be x dx of natural log of x plus ln x dx of x. Okay, if we do that, when we differentiate this, we are going to get 1 over y dy dx is equals to x times 1 over x. Okay, plus that will be natural log of x. Okay, so 1 over y dy dx is equals to 1 plus natural log of x. Bear in mind that we can say that dy dx will give us 1 plus natural log of x. Okay, multiply by y. But y is given as x raised to the power x. So therefore, dy dx will be equals to 1 plus natural log of x multiplying x raised to the power x. Hence the proof. Hence the proof. So this is what we get for our differential. So let's go up and talk about how we got to this point. In the first place, we are given y to be equal to x raised to the power x. So the differential of this will give us a certain value. We got this and that, we can be written as e raised to the power natural log of x. And that will, and since we know that e raised to the power natural log of x is equal to x, okay, so meaning that this, we bring this one out over here. Okay, then the x is still out. Okay, so if it's still, x is still out, when we multiply, then we have this. So differential of this, and you see the top here, if you see, this is what products. So what comes into our mind is we have to apply the product rule. The product rule. So the product rule. So since we know that E is just a number, it's just a base and it's just a number, so it doesn't change anything. So that when we do the product rule, we bring e raised to the power x, natural log of x out, then we apply the product rule. We know the product rule is given as, if we have y is equals to u v, for instance. So dy dx will be equals to u dv dx plus v du dx. This is the product rule. So we have applied that over here. Okay. Now, after that, we have to differentiate them individually. And we did that to that. This will be 1 over x times 1. Okay. And this will cancel, ds will cancel dx. And then natural log of x will come out. So this will be x over x, which is 1. So 1 plus natural log of that. And this all comes out. Okay. Then we say, let us consider alternative method. This wise, I say when we let y equals to x to the power x as it is be given to us, we take the natural log to both sides of this very equation. So we will have natural log of y is equal to natural log of x to x. And this can be expanded to this way. So this will be x natural log of x. Then after that, we apply product rule once again. Product rule. Okay. Then we go to this point and eventually down to this. Then we multiply y by both sides. So we have dy dx is equal to 1 plus natural log of x times y. But initially, this was given to us. So all what we do is to just substitute. So substitution, eventually, this will be our final answer. So that is so. There's two ways that we've done so far. In fact, there's all you can also use different kind of approach. You can use the Taylor series, so you can expand it, and there are so many approaches that you can take it. So our first one, as we did, our final answer we got is this one over here. Okay, then the alternative one we got that. Okay, that's what we had for the alternative one. Okay, so if you look at it very carefully, they are the same. Anyway, thank you very much for your time, and we're looking forward to seeing you around. And please, I'll urge you on to go and like the tutorial or subscribe so that will motivate us to do more. Thank you very much for your time. Thank you.